Okay, so this lesson is about absolute value inequalities. We've solved basic inequalities, we've solved compound inequalities, now we are going to solve absolute value inequalities. So the first thing we need to do is do a brief review of absolute value. So absolute value measures the distance from 0 on a number line. So for example, on this number line, 0, 1, 2, 3, 4. Here's positive 4, negative 1, negative 2, negative 3, negative 4. Negative 1, negative 2, negative 3, 1, 2, and 3. Okay, so if we're looking at the absolute value of positive 2, right, from here, from 0 to 2 is 2 spaces away, right? Same thing with absolute value of negative 2. Absolute value of negative 2, I'm just going to switch colors. We're going 2 spaces as well, the difference being 2 spaces backwards, okay? We're still going 2 spaces, but it's backward instead of forward, so therefore the absolute value of negative 2 is also 2. Again, because you're moving 2 spaces, it's just the only difference is the direction backward versus forward, okay? Likewise, absolute value of positive 4 is 4, and then absolute value negative 4 is also 4. So absolute values are always positive. Oh, sorry about the handwriting. Okay. So, I'm going to do some erasing. Okay. So, to continue with the absolute value, the second question you're asked on here, what values of x have an absolute value of 3? So that's like saying, when I say absolute value of 3, 3 spaces from 0. Okay, so from 0, 3 spaces forward is positive 3, 3 spaces backward is negative 3. Okay, 3 and negative 3. What about an absolute value greater than 3? Well, here's where we're equal to 3. Here's where we're equal to negative 3. So absolute values greater than 3, numbers right of 3 are going to have absolute values greater than 3. So 4, absolute value 4 is 4, absolute value 10 is 10, right? As well as stuff that's left of negative 3, like negative 4, the absolute value of negative 4 is 4, absolute value of negative 5 is 5. So everything left of negative 4 has an absolute value of greater than 3. Sorry, everything left of negative 3 is going to have an absolute value greater than 3. So the numbers that have an absolute value of greater than 3 are x greater than 3 or x less than negative 3. Okay, notice a couple of things here. The inequality symbols flip. One is negative and one is positive. Okay? All right, what about an absolute value less than 3? Let's redraw a number line. So here's 0, 1, 2, 3, negative 1, negative 2, negative 3. Okay. At negative 3, we're equal to negative 3, absolute value of negative 3 is equal to 3, and same with absolute value of 3 equals 3, right? So we want to know when we have an absolute value less than 3. Well, stuff that's left of 3, so 2 is certainly going to have an absolute value less than 3. Same with 1, 0. And same with, so that'll work, that'll work, that'll work. And same with like negative 1. Absolute value of negative 1 is 1, which is certainly less than 3. Same with negative 2, right? So everything that's in between all this stuff over here gives you an absolute value of less than positive 3. So let's write an inequality for what works here. X has to be less than 3, and because it has to satisfy two conditions here. Remember, this is going to be, this blue is going together, so it's an AND inequality. X has to be greater than -3. Okay, again, opposite signs, opposite inequality symbols, and opposite signs, we got +3 and -3. Okay, number 1, graph the solution to the inequality on the number line. Well, all we're going to do here is we're going to remove the absolute value bars. I'm going to go u less than or equal to 6. And then for the -1, I'm going to flip the inequality symbol. So greater than or equal to -6. Okay, let's take a look at what that looks like. So here's 0, +6, -6, less than or equal to 6, filled in circle, and then going left, right, greater than or equal to -6, filled in circle, going right, so it's going to be the stuff that's in between them. All right, absolute value of u greater than or equal to 6. So again, we'll remove the bars. We'll make our positive, u greater than or equal to 6. Make our negative, u, and we'll flip the symbol, less than or equal to -6. So on the number line, 0, 6, -6. So these are both filled in circles. Greater than or equal to 6 goes like that. Less than or equal to -6 goes like that. So notice, this isn't and, this isn't or. Okay. Number 3, you're given the graph here and you want absolute value inequality. So all this stuff is x greater than 2. The other side is x less than -2. Okay, if we think about that at absolute values, these all have absolute values that are greater than +2. Okay, because on the right side, absolute value of 3 greater than 2, absolute value of 7 greater than 2, absolute value of 10 greater than 2. On the left side, absolute value -5, that's greater than 2. Absolute value -9, that's also greater than 2. So your answer there is absolute value x greater than 2. All right, so number 4 and 5 are just like the other ones, but the absolute value is not isolated. Absolute value must be isolated. So to do that, of course we'll add 13 to each side. So that gives us absolute value x less than 6. Then we'll remove the bars, make our positive and negative. So that'll be x less than 6, x greater than -6. Let's do the graph. 0, 6, -6, and less than 6 goes left. Greater than -6 goes right. So this is an AND inequality. It's going to go in between. All right, last one. We want to isolate the absolute value v. So we get absolute value of v less than or equal to 7. Okay, so we'll remove the bars. We have v less than or equal to 7. And we also have v greater than or equal to -7 on the graph. 0, +7, -7, less than or equal to 7 goes like that. Greater than or equal to 7 goes like that as well. So this one's also an AND inequality.